I go by Ayush Gupta, and my pronouns are he, him, his. Um, I came to the US 17 years ago for my grad school, and then decided to stay over. And I started doing work in, like, my PhD was in electrical engineering, and I was working in laser plasma physics. But then at some point in time, like, I basically decided to switch over to physics education research after finishing my PhD. And that has been one of the best changes I ever made. And it's been fantastic. I love, love, love working in it. But because I also have the engineering identity, right, like about 5 years into physics education research, I got an opportunity to teach in engineering. So for the last 6 years, I've been teaching Introduction to Engineering Design in the Clark School of Engineering at University of Maryland. And I love it. I think it has transformed like how I think about teaching and learning to some extent. And that has been fantastic. It has also opened up opportunities for me to expand from physics to engineering education research. So I think that's a little bit of who I am. Also, I identify as queer. And I think that that actually ties into a lot of the way in which I think about work. So it's not like an add-on. I think it sort of like infuses. So both the sort of like things that I mentioned with respect to immigration. So immigration and queerness to me influence all of the work that I do in some way. The engineering course is structured so that for the entire semester, the students have to do a single project. And these are first-year students. Most of them are first-year students. Some of them are sophomore year students. And all engineering students at Maryland need to take this course. And for the entire semester, they're doing a single project. So when I joined, the project was building a hovercraft that will execute a mission. Sort of like it'll have to navigate through a track and then, say, retrieve an object that is located somewhere. Some sort of mission like that.
My name is Chandra Turpin, and I'm a research assistant professor here in the physics department at the University of Maryland, College Park. So it was a really interesting experiment to try to design this LA course for engineering design, tailored to engineering design. There were definitely some instructional skills and pedagogical skills that we wanted to develop that are pretty common to what you'd want to develop in learning assistants that are working in science courses or inquiry-based science courses. So a lot of skills around active learning, and learning how to draw out student thinking and respond to the ideas that students bring up in class. And then a lot of skills around what is formative assessment. How do you use that information that you're getting from students to try to think about what makes sense to do next and things like that. But then there were a lot of things that were at least played out slightly differently because we were in the context of a design-based engineering course. The LAs are embedded in regular class meeting times kind of as science LAs are. So we're working alongside other faculty members in some regular instructional time, but then they also have about a month or so into the course, they have open lab times, which is a time when teams can get together, teams from this course of about 8 students can get together to make progress on their design, and they can be doing prototyping and they could be testing and refining their approach to this design challenge. And it's in that space where there are sometimes the faculty present, but a lot of support is coming from the learning assistants and peer educators in that context. And the scope and scale of these design projects is that the students will be working on them for at least 10 weeks or so or more of the course. And so unlike a lot of science courses where you are really grappling with a concept and you kind of resolve a lot of issues maybe within a couple weeks and then you move on to a new section, a lot of the design tasks that students are facing are very long-lasting, and the teams that they're working in are also very long-lasting. So they typically work with the same group of 8 students over the course of the 10-week design project or so. And there's some really interesting phenomena that kind of emerge in the process of trying to figure out how students will manage their tasks. So one of the things we've informally observed, my colleague Ayush has taught in this course for a long time, is that students will tend to take on roles and responsibilities based on the expertise they already have. So if there's someone on the team that already has experience programming, that person tends to take the programming role. And rather than students really orienting to what are the new skills that I want to acquire, or like what's the learning that I really want to get out of this project experience, a lot of students will orient to the being successful at the challenge and like the product that they have at the end of the day, and tend to kind of optimize expertise into particular roles, which is a thing that we would be interested in helping students be more aware of, and like creating more opportunities for like kind of apprenticing into different components of a design task. We were also noticing that because it's such a long-term collaboration, like the teams can develop sort of routines and patterns for engaging with one another, some of which are maybe generative and supportive of learning, but some of which might actually kind of get in the way of people having equitable access to learning opportunities in those settings. And so those were things that we were interested in helping LAs begin to notice in the classroom, like when some students' ideas on the team were not getting like taken up or addressed substantively, or when some team members were not finding a meaningful and substantive role within the team's work. We wanted peer educators to be able to notice and consider intervening in those kinds of moments.
There's absolutely a place for learning assistants in engineering design environments. And I would say not just there's a place for them, there's a requirement for them. Right? The skill sets that they need are really different from a science or a physics class or a chemistry class or a math class. And here's a reason. If I think about what the role of the peer educator is in leading, say, a discussion section in a physics class, they're attending to, say, students' ideas. They're trying to make students comfortable in sharing their own ideas, in refining their own ideas. They're trying to get some conversation going, so on and so forth. But the class starts and the class ends, right? And then people move on to other things. And then they come back another week, there's a new topic, and the peer educators would engage the students in this new topic, so on and so forth, right? In the engineering course, however, the peer educators have to think about what are the technical difficulties that a team might be facing, right? But then they also got to think about, are there any process problems that are resulting in the technical difficulties? So for example, if a team is being unable to, say, use a sensor properly, right? And they're stuck, or they're like, oh, my sensor is not working, right? Is there a process flow problem in the sense of like, they might not have done research on that sensor previously, or for example, the other members in the team have not communicated with this member what that testing entails, right? Or this member was not part of those conversations that already happened, right? So there might be process-related things. Or for example, here's a sensor that is not working. It should not have been used in the first place at all. And so did the team undergo the process of thinking about what are all the different sensors I should be using before deciding on this sensor and buying it, and then, oh my God, like it's not working the way we want it to, right? So did they engage in the brainstorming process, or did they skip that part and go with the first idea? So essentially, when somebody is encountering a technical problem, the peer educator has to think, is this a technical issue? Is this a design process issue? Or is this a human a human communications issue, right? Or something else in the team is going down where this person is not being able to work with the sensor because they're pissed off at the team for some reason, and that is the unresolved issue, right? So what looks like a technical problem could actually be a process problem or a human problem. And now imagine a peer educator having to diagnose this, not just what is the best technical solution to this technical hiccup that has occurred in their own classroom. The second is time. So a peer educator would have to think about, like, this is a long-term project that they're executing. The way I approach and I'm helping this person now will have consequences for both the technical aspect that they're working on, but it'll also have consequences for process and human aspects. And those are long-term running. So whatever the peer educator is doing in, say, week 6 is going to affect how the team is functioning in week 12. And so the peer educator has to think carefully, am I equipping the team with resources so that they can navigate these challenges on an ongoing basis so that the process doesn't break down by week 12? And they have to think about this long-term engagement with the students. Not only that, hey, today we did circuits, tomorrow we do this, or the next week we talk about mechanics, really. So the struggles are really different, which means that the kinds of things that they're noticing and the kinds of things that they're responding to are different between an engineering design classroom and, say, a physics or a chemistry lecture classroom. Which means that to some extent, their perceptual skills have to really expand in how they are noticing. Their diagnosis skills have to really expand in how, when they are taking in perceptual information of something is broken, how do I diagnose it? And then their responding skills have to expand in some sense to think about, should I, in this particular moment, respond to the technical aspect, process aspect, human aspect, or all three? And if all three, in what order? How should I go about this thing?
You have like a lot of different hats that you have to put on. You're like kind of a teacher in that you do help students understand certain concepts. You're also a facilitator in you're not telling them what to do, you're kind of nudging them and having them come up with their own ideas for a design, for what they want for their project. You also kind of serve as a counselor and a moral support. This course involves a lot of group dynamics and group work, so you'll have a lot of conflict sometimes, and you're the person that they go to in that situation. In addition, there's going to be a lot of frustration because things are never going to work the first time. So also kind of making sure that the students are like feel encouraged, that they're not in this desperation and frustration. It's hard to balance all of them, and you don't know like when you should be more of technical, like give more technical information, or when you should be more like empathetic and like kind of balancing those things.
One of the things that we'd noticed in the pedagogy seminar was there's this ability to notice troubles that are coming up in teamwork. And our LAs had a lot of skill at that. So we would have them write little short papers on dilemmas or like teaching challenges that they were encountering and briefly describe scenarios, like what their observations were, descriptive accounts of trouble that they were observing. And then what we would do sometimes in the LA Pedagogy Seminar is choose some of those scenarios to role play. So in our pedagogy seminar, some of the undergraduate learning assistants would pretend to be students in the scenario, or like people on this design team working together. And then one of the LAs would pretend to be the LA in the situation. And so we would, and the rest of the class would often watch this role play out and try to determine what kinds of things do they notice the educator doing, what kind of impact do they see those instructional moves and actions having on the dynamics of students. And then we would sort of like critically reflect on like what sorts of things we thought worked or didn't work well for particular kinds of instructional goals or like learning goals. And it was really interesting to us that students strongly hesitated to reflect on social dynamics that they thought were not very smooth or not very healthy. They would be willing to do smaller moves to draw out the thinking of students that were more quiet, but they were very hesitant to sort of call out other students that might be kind of overbearing or intervening and interrupting over other students. They felt like calling things out more directly could leave a lot of awkwardness and uncomfortableness in the team dynamics. And so we're still really trying to hone how do we help students develop a toolkit of possible responses for addressing like inequities and like teamwork troubles that they might encounter in these design contexts. But these role plays did seem very effective at helping students notice notice teamwork troubles and being able to begin to build this toolkit of possible ways of interacting with and responding and intervening to troubles that they were diagnosing in the classroom.
Yeah, so having a group work well together is really important, not just in engineering, just in any group project in general. We actually did read a couple of papers on the importance, but to me, I think, you know, to get a job done, you need to be able to cooperate with your peers. And there's just so much more motivation when you like the people that you're working with and when it feels more like a fun thing than just work. And so I think that group dynamic defines a lot of that. And so that might not always happen. You will have conflicts. And in those situations, I think I would have some people come up to me with the conflicts and trying to be very empathetic with them and really kind of seeing the situation from all perspectives and trying to have the students also be empathetic with whoever like is the source of conflict is important. I'm going to be honest, in some conflicts, I didn't know how to handle it, so I did have to go to Ayush, who was my professor, to ask him how to handle it.
Yeah, one of the things that the peer educators in this course context, the LAs, found really useful was a concept that we exposed them to from Angela Little's work, which is around proudness. And so these long-term project-based designs, you can kind of lose track of like when and how you're making progress. Like the end product goal can feel so far away and distant that there can be a lot of struggle and frustration along the way. And so the peer educators and us as instructors of the pedagogy course really found a lot of traction with these ideas of proudness. How do we help students to recognize and kind of mark the progress that they're making and recognize some of the successes that they're having along the way, rather than being solely focused on the product at the end of the day. So like noticing successes in the work that they're doing, the small successes in the work that they're doing along the way, instead of just a focus on the like, does our overstand vehicle or OSV like function and accomplish the challenge at the end of the day.
For the learning assistant pedagogy seminar, one of our goals was that we can expand what counts as success, both for the peer educators and for the students of the peer educators. So the peer educators, remember, are working in an engineering design course. And in the engineering design course, some of us were dissatisfied with the emphasis on being able to finish the project, being able to, say, win a competition. And we wanted to expand what counts as success in that space. Right? And so success could include, you know, successfully navigating team dynamics, you know, innovatively navigating setbacks that are bound to arise in an engineering design process, and, you know, sort of like regarding navigating those challenges as something to be proud of, right? Even having fun while doing engineering as something to be proud of, right? And so how do we do that? And we thought that if we can make the expanding notions of success as one of the goals in the pedagogy seminar, then maybe the peer educators, the learning assistants, would be able to help the students in the engineering design course do the same thing. And one of the tools by which we thought this could be achieved was to read Angie Little's Proudness article and have a discussion on it, both in terms of what do the peer educators want to feel proud of as peer educators, but also what are the kinds of things they want their students to feel proud of. Right? And for a bunch of the learning assistants, this article really struck a chord, both in terms of thinking about what are the kinds of things that I feel I'm growing as a peer educator, and what are the kind of markers that I should document in my growth journey. And some of these ended up in a portfolio that the peer educators, the learning assistants, created in the pedagogy seminar. So at the end of the seminar, they created this presentation with a few slides showing their journey across the semester, maybe their first day as a peer educator, but also showing how their relationship with the team evolved, or some artifact that they created as part of the course and as part of their teaching that they feel really proud of. So they were documenting their own proudness, their own growth. Right? But the thing that was really surprising was that some peer educators took it into their own classrooms and really started engaging the students in dialogues of proudness. And so this happened in my own classroom, where we were meeting with all of the engineering design teams individually to very early on in the semester, to give them a chance to ask questions to us, to the learning assistant and to me, who was the instructor in the class, and also to get to know us, and so on and so forth. And the particular learning assistant I was working with in that in the engineering design course, who was also taking the pedagogy seminar, suddenly started asking the teams, I want you to really articulate, what do you want to feel proud of at the end of the semester? What are your proudness goals? And, you know, as an instructor of both the pedagogy seminar and the engineering design, like that's like a proudness moment for me, but also like my jaw dropped that she could articulate that question so well and engage students in addressing it. It was an eye-opener that this can happen. And then at the end of the semester, we visited again, like, you know, what do people feel about their proudness goals? Do they think they achieved it? Do they think they not achieved it? I think we didn't do as well in asking people to collect artifacts. Though people do take pictures and videos of their work, but they could have done a little bit more. So this semester, we have introduced another revision to highlight this really productive and powerful idea of proudness more in our course. So I'm working with the same peer educator again in the engineering design course. And so what we did was we gave a homework assignment, which was team-based. And so there were two kinds of things to happen. One is the team needs to go and do something social together and then report back, you know, just a couple sentences on whether they did it and how did it go, right, very early on in the semester. And then the team as a whole also needs to meet and sort of like articulate what are the things that they want to feel proud of at the end of the semester. Okay. For the first one, I had thought that people will only write a couple of sentences on what kind of social activity they engaged in. But what ended up happening is that 3 of the teams took pictures of them doing some social activity and then handed that in. In some sense, they're already starting to generate artifacts towards team dynamics and their relationships they're building within the team. And then almost every team noted their proudness goals to include building these human relationships, to include aspects like all of us want to learn something that we didn't enter the course learning, which is a great thing, which is different from saying I want to get an A in the course, which is different from saying I want to get my engineering project working. It is saying I want to learn something that I didn't enter knowing in advance, right? And so that assignment essentially became an opportunity for us to write comments. And so in the comments, we have started asking students, what are the kinds of artifacts you would want to collect on the way in order to address this proudness goal and that proudness goal and that proudness goal, and then add some of our own suggestions to the kinds of artifacts they could be collecting, right? And we want to do more this semester in sort of like periodically revisiting these proudness goals to see whether we as instructors are doing enough to create opportunities in the learning environments so that students can meet their proudness goals. Right? And another nice thing was midway through the semester, the students have to make a presentation for their preliminary design. Multiple teams, instead of simply saying that, hey, our goal is to do this mission, right? They started listing their proudness goals as part of what they want to achieve during the semester in a formal presentation with external people who they have, like engineering professors who are not their immediate instructors. Those were people in the room evaluating these presentations. And these students were listing their proudness goals in that presentation, which was amazing.